Okay, so now we are going to do confidence intervals. We're estimating the mean when the population standard deviation is known. Because of time and money constraints, it is difficult to find in population members. Of course, again, we're going to take the sample and we're going to base it, the sample information, make a deduction about the population. So assumptions, simple random sample size of n, the population standard deviation is known, and the x distribution is normal. Point estimate, the mean is the point estimate for the population mean. Confidence level, the reliability of an estimate will be measured by the confidence level. Confidence level C, where C is usually such numbers 0.90, 0.95, 0.91. Critical value, C of C, I told you if you go to page 370 in your textbook, you would see that they have a list of all of the level of confidence, and then the critical value. I suggest you copy down the table. It's on page 370 in the pink. Remember, if you're going to do it by calculator, inverse norm, we're always going to use the positive value. But again, I would go to page 370 in your textbook. So we're also going to find the maximum margin of error, which is the z, which is your critical value, times standard deviation over the square root of n. To find the confidence interval, we're going to do test 7, and we're going to put in population standard deviation, the sample mean, the n, and the confidence level. Next, we're going to find the minimum sample size, which is n equals the critical value times standard deviation over the margin of error squared. We always round up no matter what number you get. No matter what number you get. Next, we're going to turn to page 378 and we're going to look at some problems. If you look at number 15, 15 is talking about Allen's hummingbird. So A, it says find an 80% confidence interval for the average weights of Allen's hummingbirds in the study regions, and then it asks what's the margin of error. So the first thing is we're going to put this into stat test 7. We're going to put the numbers in. It's an 80% confidence interval. So we're going to do the confidence interval, which is here. 3.0408 is less than the mean, which is less than 3.2592. And then we're going to find the margin of error. 1.28 is your Z of C, which is your critical value, times the standard deviation over the square root of 15. You get 0.11. Then they tell us to do an interpretation where we say we are 80% confident that the population 3.15 is between 3.0408 and 3.2592. Then on D, it's going to tell you to find the sample size. So you're going to take the critical value times 0.33. They gave us the E this time of 0.08, and we get 27.878, which rounds to 28. Then on 13A, they ask us to find the minimum sample size. And again, they give us the E. So it's just a matter of plugging into the formula. It's just a matter of plugging into the formula. 14A is the same thing. 14A is the same thing. And then 18, they asked us to find a 90% confidence interval. And this is where we're going to do stat test 7. And here I would round, which I didn't do, and use the dollar signs. I would definitely use the dollar signs, which is a little difficult to do when I'm here at the computer. So when we do the 90% confidence interval, we get 6.3807 is less than or equal to mean, which is less than or equal to 7.3793. The E is 50 cents, and that's using, and then the sample size is 111. So just when you're doing this, make sure you put in the dollar sign. So this should be 6.38 is less than the mean, which is less than 7.38. All right, with dollar signs, because we're talking about dollar signs. All right, so that concludes this first half of the lesson.